Hello everyone, this is Chandan from Sri Venkateswara College of Engineering. In this video, let's learn about insertion sort.
Now in this lesson we are going to talk about insertion sort. Insertion sort is not the best sorting algorithm in terms of performance, but it is little more efficient than bubble sort and selection sort in practical scenario. Insertion sort is also pretty initiative sorting technique. So let's see what it is. To explain the logic of insertion sort, I will once again use the example of cards. So let's say we have a set of cards in our hand and we want to arrange these cards in increasing order of rank. These are couple of initiative way to sort the set of cards in our hand. One of the thing that we can do is initially we can keep all the cards in our left hand and we can start taking cards one by one from the left hand and we can start building a sorted arrangement in the right hand. Our first card is 9. There is no other card in the right hand, so 9 will be simply go into right hand. Now we will take next card in our hand, which is 3 in this case. Now when we will take 3 to the right hand, we will insert it before 9 to make sure that the cards are sorted. At any stage during this whole process, the left hand will be unsorted and the right hand will be sorted. Now the next card that we will pick up is 6. Now we will take 6 to the right hand. It will have to be inserted between 3 and 9. Now the last card that we will pick up is 4. And 4 will have to be inserted between 3 and 6 in the right hand. And finally we will have to be sorted arrangement in the right hand. I have used 2 hands here, but if you see, this can be done in one hand also. This idea is pretty simple. What we are basically doing is we are dividing the sort of cards into two subsets, a sorted subset or a sorted part and an unsorted subset or unsorted part. Initially all the cards are unsorted subset and the sorted part is empty, and we are picking up one card from the unsorted part at a time and inserting it into the sorted part. Let's say we have something like this. We have a boundary here and let's say cards to the left hand to this line, this vertical line are sorted and the cards to the right hand to this vertical line are unsorted. So initially all the cards are in unsorted part. Now we will pick up one card at a time and insert it into the sorted part. If there is just one card, we will similarly move it. Now we pick up the next card from the unsorted part. It's 3. It will be inserted before 9 in sorted part. Now we will pick 6 and 6 must be inserted between 3 and 9. And finally we will take 4 and 4 must go between 3 and 6. It should be inserted between 3 and 6. And we are done once our unsorted subset is empty. Now we want to write a program to sort a list. We can do something similar to what we did for these cards. So let's say we want to sort a list of integers given to us in the form of array. Let's call this array A. We have 6 elements in the array, so we have to indices from 0 to 5. What we can do is we can start by saying that we will divide the array into two subsets. Initially elements till index 0 will be part of sorted subset or sorted off, because if you have one element in a set, the set is always sorted and all other elements are part of unsorted subset. And now we will go on picking up elements from the unsorted subset and we will keep on inserting them into the sorted subset. So we will kind of keep expanding the sorted substance till unsorted substance becomes empty. At any stage, let's say the cell in blue are part of the sorted subset. Now at this stage I will pick up 2, which are the first element in the unsorted subset. Programmatically this will mean storing the value in some variable. Let's say the name of the variable is value. So all we have done is we have said something like value a1, but for the sake of understanding let's assume the position, and what we have created a hole there at the particular position. Now what we will do is to insert 2 into the sorted part into the sorted subset. We will shift all numbers greater than 2 in the sorted part by one position to the right. We will have only one element at this stage in the sorted subset, 7, which is greater than 2. So 7 will be shifted one position towards right and the hole will go to position 0. And now we will fill up 2 at position 0. We will fill up 2 in the hole and now we are sorted till index 1. Now once again we will pick up the first element from the unsorted part. So we will create a hole like this. Remember, there is no actual taking out of 4 from this position. We are just filling up 4 in the another variable and assuming there is a hole for particular position. Now once again we will shift all the number greater than 4 by one position to the right. We will do so on by 1. We will start position 1 and see the number is greater than 4. 7 is greater than 4, so we will be shift to intent 2 and hole will now move to index 1. Now we will look at 2 comma 2. 2 is not greater than 4, so no more shifting is needed. We will simply put 4 at index 1 and now we are sorted till index 2, and now we will get pick one from the unsorted part, and once again we will start shifting all the elements greater than 1. In the sorted subset, one position towards right. 7 is greater than 1, so we will shift it and the hole will now move to index 2. Number 4 is also greater than 1, so it will also shift. Number 2 is also greater than 1, so hole will shift to 0 and we will not have any more numbers greater than 1 to be shifted. We will move 1 to this hole and now we are sorted till index 3, and we will repeat the same insertion logic for 5 and 3 as well. For 5 will have to be shift only 7, and for 3 we will have to be shifted 7, 5 and 4. So finally 3 will go at index 2. So finally we have a sorted list. This particular in place logic of shifting and inserting element to sort a list of insertion sort algorithm. And now let's quickly write pseudocode for this algorithm. I will write a function named insertion sort that will take 2 arguments, an array and the number of elements in the array. Let's say the name of the array is A and the number of elements in the array is n. Now initially we are saying that we are sorted till index 0. So we will pick up elements from 1 till n-1, and at each step we will insert the element at its appropriate position in the sorted subset. So in our code we will run a loop starting index 1 till n-1, and first we will create a hole by taking out the value to insert in another variable. So temporarily we will keep ai in this particular variable. Then I will take another variable to mark the position of the hole, and then I will take another variable to mark the position of the hole, and at this stage the hole is at index I, and now we need to shift all the elements greater than the value to be inserted one position to the right, while hole is greater than 0 and the element at the index hole index hole -1 is greater than value. We will shift the element at index hole -1 to the hole. So now our new hole will be index hole -1. When we will find a smaller element than the value in the sorted subset, this particular condition will be false. We will exit the while loop, or we will exit the while loop when hole will be equal to 0. So there will be no more element to shift, and finally we will come out of the loop. We will put the value into the hole, and this is our pseudocode for insertion sort.